Okay, today we're looking at constant acceleration formula. I'm not going to go through the derivation of all of them, but you can, if you want to have a look at that, look in your text. Pages 532 and 533 is the derivation of them. Alright, what are they? The following. There's four main ones. And the final one is that one there. Okay, so you'll notice that each of them have something that they're missing. So there's a few different variables, and the variables are U is initial velocity, V is final velocity, A is the acceleration, which will be constant, that's why it's called constant acceleration, T is time, and S is displacement. Alright, so they are the four constant acceleration formulas. Each of them has one of those things not in it. Alright, a couple other quick things. If we're talking some notes, if you like. Number one, at rest means that velocity is zero. The second thing is metres per second to kilometres per hour. You times by 3.6, and obviously if going the other way you do the opposite. The third thing is acceleration due to gravity is 9.8 metres per second. Alright, so it's a matter of us using these formulas. Okay, so here's our first example. Stone is dropped from a bridge 150 metres above the river. Here's our bridge, and here's our stone. It goes down here and splashes. Alright, so that's 150 metres up there. Find the time taken for the stone to reach the river. Okay, so there's a couple of things. The distance that it travels is 150 metres. The acceleration is the acceleration due to gravity. Now, there is a bit of an issue because we've got two directions, we've got up and we've got down. The way I like to do these questions is to always take up as being the positive direction. So, if up's the positive direction, then S actually is negative 150 because it's travelling in the down direction, negative. Acceleration due to gravity, it's just gravity that's pulling the stone down. So, again, it's pulling it down, so it's in the down direction, negative 9.8. The other thing that's implied in there is it's the initial speed. And the initial speed, if you're dropping the stone initially, it's at 0. And we're after time. So we look back at those formulas and see the one that's got everything other than final velocity. So when we come back here, have a look at that. The one that has everything but final velocity. There it is there. So S equals ut plus a half at squared. So negative 150 equals 0 times t plus a half times negative 9.8 t squared. And then it's a matter of you're now rearranging, and when you rearrange, divide by negative 4.9 and then square root, you find that the time is 5.53, and you're asking the question to the nearest tenth, so it's 5.5 seconds. Okay, in the second part, part A says the speed on impact. Okay, so what do we know? We know the distance travelled is negative 150, the acceleration is negative 9.8, its initial speed was 0, and we're after finding the final speed. So we need to go for the one that hasn't got time in it. So if we come back here, the one that doesn't have time in it is this last one. V squared equals u squared plus 2as. So here's that, v squared equals u squared plus 2as. So 0 squared plus 2 times negative 9.8 times negative 150. So now when we do that calculation, we find that v squared is 2940, and so v, when we square root it, comes out 54.22, and we want the nearest, so it's 54.2 metres per second. Okay, this next example, this is the last example I'm going to be doing. So a ball thrown upwards at 14.7 metres seconds from the tower, that's 50 metres above the ground. Determine the total time the ball is in the air before it reaches the ground. Okay, there's a couple of things you've got to be careful of here. So here's our thing, as the ball goes up and comes down, hits the ground. Okay, so things you've got to be careful of are where your 0 point is, so where you're starting, and with these things, it's usually easy if you take that as your 0. So we're told that the tower's 50 metres high, so actually when it reaches the ground here, its displacement from the 0 point there is in the down direction, and if I'm taking up, as I always do, as positive, then the displacement when it hits the ground is negative 150, negative 50, not 150, negative 50. Okay, so it's 50 metres below where it started. So usually always easier if you take your 0 as the starting point. Alright, so what have we got? Information. We've got that S, the displacement's negative 50. The acceleration's due to gravity, negative 9.8. And our initial speed is this time is 14.7 upwards. So that's plus 14.7. Alright, what are we after? Time. Okay, so we go back to the one without final speed in it, and it's the one I've already got. It's one without B in it. Oops, too far. There we go. So S equals UT plus half AT squared. So negative 50. Okay, so then we get a quadratic 4.9t squared equals, minus 14.7t minus 50 equals 0. And then you've got to solve a quadratic equation using the quadratic formula or whatever. And when you do that, you get two answers. You get negative 2 and 5. Okay, now in these sorts of examples, the negative times make no sense. So the negative times out, and so it's 5 seconds. Alright, part B asks us to find the speed when it hits the ground. That's what we're after. Acceleration, displacement. Okay, and so this time V squared equals U squared plus 2AS is the one we're going to use again. Alright, negative 50. And then you figure that out, and that's 1196.09, and then square root that, and you get 34.5845. Correct to 1 to the nearest tenth, 34.6 metres per second. Alright. So there's it, that's the third question set, that's exercise 15C out of your textbook.